Thank you everyone for coming today. Welcome. My name is Caroline Graham and I am the Chinook Technical Committee Coordinator for the Pacific Salmon Commission. Thank you very much for joining the seminar today. This is the 11th installment in the PSC Seminar Series. If you are interested in any of the past seminars, they are all available on the PSC website. And as a reminder, today's seminar is being recorded and it will also be posted on the PSC website. Today's seminar is titled Supporting Salmon Recovery Through Strategic Initiatives. And we have two great speakers today, Bill Templin from the US and Shane Petersen from Canada. And as a reminder about the order of operations, each speaker will give about a 25-minute presentation, and then we'll take a short break and come back for a Q&A session. So if you do have any questions during the presentations, be sure to type in your questions using the Q&A function at the bottom of your screen. So I'll start by introducing our first speaker today, Bill Templin. So Bill will be discussing the management of Alaska's fisheries in the presence of change. And Bill is the Chief Fishery Scientist for salmon at the Alaska Department of Fish and Game in the Division of Commercial Fisheries, where he oversees the division's statewide salmon biometrics, research, and laboratories. His background is in population modeling, genetics of commercially important fish and shellfish species, and the integration of science with fisheries policy and management. He currently represents the state of Alaska in various statewide, national, and international settings, including the Pacific Salmon Commission and the North Pacific Anadromous Fish Commission. So thank you so much, Bill, and I'll hand the floor to you.
Well, good afternoon, everyone. Again, my name is Bill Templin, and Chief Fishery Scientist for salmon at ADF&G. And my task today is to present an overview of the systems used by the state of Alaska to adaptively manage the salmon resources, with an emphasis on the principles and processes that guide the process through changes. This first part on Alaska's management system is necessary because it forms the foundation upon which information needs become apparent, strategic initiatives are developed and shaped, and the results are ultimately used to improve outcomes. The short version of this talk usually takes about 45 minutes, but I only have 25, so I'm going to cut out a lot of information. I may cut some corners. Feel free to ask me questions about them when you have opportunity. Alaska is in the heart of the salmon world. Geographically speaking, we're smack dab in the middle of the productive range for Pacific salmon. Salmon are also at the heart of Alaskans. Salmon aren't just another fish in Alaska. They're our lifeblood, is kind of a way it's been phrased. But they're also very important to our identity. As we all know, the world is a changing place. Things are happening, major things are happening, and they're having big effects that we're just now beginning to feel. For one, when changes happen within the ocean, it affects salmon because salmon depend on marine waters as juveniles and at older ages as they mature. This makes them susceptible to large-scale events such as the recent recurrent marine heat waves that have happened in the Gulf of Alaska and the Bering Sea during this past decade. We also need to remember that major changes to the landscape are a mixed bag for salmon. This recent study shown here looked into the potential effects that glacial retreat might have on salmon productivity in freshwater systems. And it indicates that the harm and benefits will vary among species, life stages, stages of change in the landscape, and locations. Alaska became a state during a long period of decreasing harvests and low productivity. So the principles and processes to handle change were built into the state's resource management from the very beginning. As you can see from this graphic, statehood happened in 1959, about the middle of this time series here. And you can tell that it happened during a period of very low productivity and decreasing productivity. Even after statehood, production remained low. After a low in 1975, in 1976, it began to increase, and it's increased to the productivity that we see now. Now, there were three closely associated events with that low point, not just the creation of the hatchery program, but there was an ocean regime shift in 1978, 79, and the Magnuson-Stevens Act in 1976 moved foreign fishing fleets further out from state waters and relieved many of the stocks from the unrecorded harvest pressure that was happening during that time. Alaska State Constitution itself sets out the principles for resource management that allow for flexible and largely local management of resources. Capable of acting in more flexible and nuanced ways to address challenges such as human uses and/or climate and environmental change, these principles allow for careful management. The principles are, here's an example from the Constitution in Article 8, Section 4, the fish, forests, wildlife, and grasslands and all other replenishable resources belonging to the state shall be utilized, developed, maintained on the sustained yield principle, subject to preferences among beneficial uses. As the management entity on behalf of the state, ADF&G has the responsibility to protect, maintain, and improve the fish, game, and aquatic plant resources of the state, and to manage their use and development in the best interest of the economy and the well-being of the people of the state, consistent with the sustained yield principle. This delicate balance between seemingly conflicting charges is reflected in the words of the presiding principle. Sustained yield contains both the responsibility to provide for resource uses in the present and the responsibility not to endanger the use of the resource in the future. The cornerstone of the system to achieve this balance and ensure, as far as possible, the sustainment of future yields is the use of escapement goals for management targets and evaluation. The escapement, for those who don't know, is the number of fish that actually make it to the spawning grounds to spawn. Using goals for escapement are set to provide yield, that's harvest and other uses, not just for conservation. Harvest decisions and regulations are determined based on these escapement goals. These goals are well above levels that cause conservation concern, and thus actions and concern about salmon production can happen early when it still can be corrected. Alaska's management process starts with an understanding of the productivity of the system. This could be for a stock or a group of stocks. From that, we develop an escapement objective and a management plan. We then manage the harvest to achieve that goal and allow for yield. We can measure how we've done there by counting the fish in escapement and the fish in the harvest. In some situations, we can segregate the harvest between hatchery and wild or between individual stocks. Using those two types of information, we can then measure the success we've had with managing harvest to meet these escapement goals. An essential part of the fisheries management process is the Board of Fisheries. A board of 7 members of the public serves as the main decision-making panel on matters of regulation, policy, allocation, and management plans. This effectively separates the executive branch from these important issues and provides a means for the public to provide meaningful input. I apologize for the late clicking here. It's hard to see which screen I'm actually working on. While at times inefficient, unwieldy, and painful, this structure provides the mechanism through which local observations and stakeholder concerns about changing productivity and accessibility are heard, and a wide range of potential actions and responses are explored. The Board of Fisheries fits into the process at this point, mainly through a review of performance, deciding on escapement goals for management, adjusting plans for management, and setting regulations and policies. As noted before, this is where the decisions about allocation of the resource fits into the process. One of the main policies developed jointly by the department and the board is the Sustainable Salmon Fisheries Management Policy. Within this, the principles read a bit like the list of recommended actions at the end of a climate change review paper. First, protect wild salmon and habitat. Manage for escapement ranges to sustain production and consider uncertainty when doing that. Develop effective management systems. use a precautionary approach to human activities, encourage public support and involvement, and manage conservatively, commensurate with the uncertainty that exists in the system. Next, I've added this slide about timescales that need to be accounted for when considering actions in the face of change. I found this to be useful to allow us to see how data collection, biology, regulation, management, and the environment all operate on different time steps, adding to the complexity of management systems. You can see data series can be in terms of decades and centuries. Salmon life cycles happen between 2 and 7 years. Regulatory cycle happens about every 3 years. Assessment can take place in days to weeks. Environmental changes can take tens to hundreds of years, or they can take decades, or they can take into a single year, a single season, as we've seen with marine heat waves. So this leads us to strategic initiatives in Alaska. Alaska's management is data intensive. It requires data on assessment, which would be counting fish, as well as research, like what are the potential causes for a decrease or an increase. It also involves information for tracking. Where are the fish and when are they there? Or measuring things like the age and size at return. This level also is data, requires information like marking and tagging, as well as genetics. This can generally happen at the local scale on an individual stock or set of stocks or in one area. However, some issues require a large scale and coordinated effort. Statewide production trends, gauntlet fisheries, migration shifts, these all happen beyond the local scale. When we do that, we begin to deal with multiple stocks, multiple fisheries, and of course, multiple user groups also. It's expensive in both funding and resources, so it needs to be focused. It should have a clear goal, achievable objectives, answerable questions, and of course, an appropriate design. And again, once you've done that, you need to give thoughtful application while designing it through the process and at the end when you have the information. How will this information be used for decision making? Of course, all of this happens at the wide scale, and in Alaska, that's when we tend to think of it as an initiative. So, what types of strategic initiatives have happened in Alaska? I'm going to break them into 3 categories depending on the type of information that's needed. First is assessment. When we need to assess something on a wide scale, say a statewide scale, we've had to set up a strategic initiative. The most recent one was the Chinook Salmon Research Initiative, in which a statewide decline in Chinook salmon runs required a statewide approach to fill data gaps in assessing the escapement, the harvest, and things like survival. The CSRI lasted 8 years. It was built around 12 indicator stocks. It involved both the state and the university. It cost about 15 million, and really it should have cost about 30 million, but funding was cut when the economy took a downturn. But in total, there are more than 20 projects, individual projects involved in that initiative. More information can be found at this website below. Sometimes an initiative might have to do with management, such as the Western Alaska Salmon Stock Identification Program, known around here as WASIP. Multiple times throughout the state history, low runs in Western Alaska have raised concern about allocation of salmon resources and harvest in distant fisheries. So in 2004 and 2005, a group of 11 stakeholders got together and formed the WASIP initiative. Those 11 stakeholder groups formed the advisory panel, in which local users, local concerns, and local communities could all take part at the table through their representatives. In addition, it included 4 independent scientists on the technical committee. It dealt with 2 species, sockeye and chum. It was so large that we needed to develop coast-wide genetic baselines. all harvest in all the fisheries. You can see on the map here, and color-coded are the places where fisheries happen. All those harvests were sampled for 3 years. In total, 250,000 samples were collected, and of those, 150,000 were genotyped. It cost about $10 million US, and it took 7 years to complete and report. And again, that whole initiative can be found at this website here. Finally, there are questions about human uses, such as enhancement. The Alaska Hatchery Research Program, or the Hatchery Wild Interactions Study, is a good example of that. It was driven by concerns about interactions between hatchery and wild salmon, and the potential impact on wild salmon production, which gave it motivation for a comprehensive program to collect basic information so that the state could make changes if necessary to the program. This is one I'm going to talk more about this because this one is ongoing, and it's relevant to some of the talks that have already been given in past talks on this seminar series. So I thought it might be the most interesting to this audience. Again, information can be found at this website, and I will mention some papers that are also available. So background for this initiative, back to that image that I showed earlier, you saw that the hatchery program took place at a record low in Alaska harvests, 1974. The hatchery program was begun, and hatcheries began to make substantial contributions to harvest in the 1980s. As you can see from this graph, which shows hatchery fish harvest in blue, Alaska hatchery releases have leveled off since about the 1990s. Currently, the majority of juvenile salmon released annually by PNP hatcheries, that's private nonprofit hatcheries, are pink salmon in Prince William Sound and chum salmon in Southeast Alaska. And these together account for more than 2/3 of the Alaska releases. In Prince William Sound, about 800 million pink salmon and 150 million chum salmon fry are released from hatcheries each year. While in Southeast Alaska, another 600 million chum salmon fry are released from hatcheries. These large-scale hatchery salmon releases raise concerns for the productivity and sustainability of wild stocks. Among the concerns are the potential for straying hatchery fish to compete and interbreed with wild fish. This is not a new concern. Alaska was the first state to have a genetics policy in 1985, which was designed to reduce the potential for genetic impact of hatchery origin fish on wild stocks. For a variety of reasons, large-scale hatchery production has come under intense scrutiny. And the issue is not isolated to Alaska, as all salmon nations have increased production similarly over the last 4 decades. You can see on the top plot there from the NPAFC, the production from Canada, Japan, Korea, Russia, and the United States. As you can see from that graph, Japan was the first country to ramp up releases in the 1950s. Canada, Russia, and the United States all started bringing hatcheries into production in the 1970s, and releases have stabilized since the early 1990s. Currently, the nations surrounding the Pacific Ocean release 5 billion juveniles annually from hatcheries. Alaska accounts for about 30% of the worldwide Pacific salmon hatchery production. In the request for, So question remains, or came up. Do hatchery fish detrimentally impact productivity and sustainability of wild stocks in Prince William Sound and Southeast Alaska? Areas of risk include genetic, ecological, disease, and harvest. Alaska policy mandates that we manage these hatcheries and the fisheries sustainably for productivity of wild stocks. Built into our regulations and statutes are statutes that directly relate to protection for wild fish. So while hatchery programs evolved, the need to protect wild fish was recognized in a variety of policies and statutes. These statutes, regulations, and policies offer important conceptual protections for wild fish. But there is an ongoing need to recognized in the policies for assessment to inform decisions. As the hatchery programs evolved, the need to protect wild fish was recognized also in policies that were developed. These policies include a genetics policy from 1985, as mentioned previously, where it says the priority will be given to the protection of wild stocks from possible harmful interactions with introduced stocks. There's also a policy for pathology, which is actually written into statute. It requires information like a disease history, control, and inspection of hatchery fish to control transmission of disease in hatcheries and into the wild populations. Likewise, we have fish transport permits and a whole permitting system developed so that there's oversight over the whole activity of enhancement. With the advent of new genetic techniques and parentage analyses, investigation into the reproductive success of hatchery origin fish in the wild has exploded. Most of these studies found that fewer progeny were produced by hatchery origin fish than natural origin fish when spawning in the wild. However, there is a lot of variability among species, year, sex, and broodstock origins. At the time this initiative was designed, most published studies were on steelhead, chinook, and coho. For Alaska, this new information was a benefit, but it was also a problem. Most studies were done on species with different life histories than the species predominantly used in Alaska. None of these fitness studies were conducted in Alaska. Most fitness studies were conducted in areas with compromised habitats, using small broodstock sizes or non-local stocks. And they were also designed for programs which were designed for mitigation and conservation rather than to provide harvest for fishermen. These differences made it difficult to apply the published studies to Alaska's hatchery program. For example, the difference in life histories for salmon in published studies and the life histories of the two species most used for supplementation in Alaska are likely to have an effect on relative return per spawner in spawning streams, or the productivity of hatchery fish in these spawning streams. So you can see here there are 6 Pacific salmon salmonid species. This image is just to depict the lifespan and what portion of the lifespan that these individual species might spend within a hatchery. Pink and chum salmon eggs are incubated in hatcheries and are released into the ocean soon after hatch, only experiencing about a 10% mortality from egg to release. Other studies looked at species that have longer residences, where there's more opportunity for domestication selection. To this point, no studies have been conducted on pink salmon, and only one study has been done on chum salmon, where no significant effect was detected. Most of the previous studies have investigated chinook salmon and steelhead. Recognizing the need to examine the extent and effect of hatchery strays on wild stock fitness and productivity, private nonprofit operators asked the ADF&G to organize a science panel of experts to design and implement a long-term research project to inform future resource management decisions. The Alaska Hatchery Research Science Panel was formed in 2011 to design a study that would provide the information all stakeholders need to understand potential effects of hatchery-wild interactions in Alaska. The program was funded through a tripartite partnership, including the state, processors, and PNP operators. This effort focused on the 2 primary species where the least research on interaction effects was available, pink and chum salmon, and the 2 regions with the largest hatchery production, Prince William Sound and Southeast Alaska. At the head of this this program was the science panel. I'm going to just present here. Many of these people you might recognize, but I wanted to show you that the The science panel included scientists that represented both government, federal and state, industry, hatcheries and processors, and the university. The Alaska program is broadly overseen by this science panel, and the state oversees the laboratories with specific roles in the analyses and administers contracts for the field work to the contractor. Contract work was done by 2 regional science centers. Funding for this program was the result of a partnership between government and private sources. The total funds anticipated to complete this program stands at about $17 million, excluding substantial in-kind contributions from the Alaska Department of Fish and Game. The first job of the science panel was to pose answerable questions given budget constraints. The science panel came up with 3 questions that could be answered using scientific methods. These were: what is the genetic stock structure of pink and chum salmon in each region? What is the extent and annual variability in straying of hatchery pink salmon in Prince William Sound and chum salmon in Prince William Sound and Southeast Alaska? And what is the impact on fitness of wild pink and chum salmon stocks due to straying of hatchery pink and chum salmon? At this point, and for time, I will skip over large portions of the methods and results to provide a snapshot of the types of information that the initiative is providing. Over the next several years, we will be completing field work and laboratory analyses, analyzing the data, reporting results in light of management needs and current scientific understanding. So, first question: what is the genetic stock structure of pink and chum salmon in each region? We found the population structure does exist and is shallower in pink salmon than in chum salmon. Drivers of structure in pink salmon were an even versus odd year division, and that there were deeper divisions deeper structure in the odd year lineage than there was in the even year lineage. For chum salmon in Prince William Sound and in Southeast Alaska, there was good structure that was related both to run timing in Southeast Alaska, the summer and the fall runs, as well as geography. You can see clumps in here. The orange is Prince William Sound populations. The pinkish is Yakutat, which is in between Prince William Sound and Southeast Alaska. And the blue is geographical separation within Southeast Alaska. The second question was about the distribution and variability of straying in the 2 regions. This was designed in a way that would allow estimation of stray presence across both districts and regions. For pink salmon, our annual proportion of hatchery origin spawners, when aggregated by district, is represented in this graphic here. The blue portion, or the bars within each square, represent the 3 years of the study: 2013, 2014, and 2015. The blue portion of the bar is the wild origin or natural origin proportion in the streams of that district. The red portion of the bar then are the hatchery origin proportions for the streams in that district. As you can see here, there was definite geographic pattern within straying of hatchery fish into wild streams. On the whole, the regional annual proportion of hatchery origin spawners in all the streams of Prince William Sound was about 5 to 15% across years. Chum salmon, a similar plot for chum salmon demonstrates that a similar pattern of the southwest corner of the sound having greater presence of hatchery origin salmon in these streams. Overall, for the whole run of chum salmon in the streams for those 3 years ranged from 3% to 9% for the whole sound. In Southeast Alaska, we saw a slightly different pattern. The annual proportion of hatchery origin spawners by district in the 3 districts of Southeast Alaska are depicted here. Again, blue is the natural proportion and red is the hatchery origin proportion for the 3 years. You can see that it was small in those 3 years, much smaller than the southwest portion of Prince William Sound. When aggregated across all of this region, all of Southeast Alaska, it amounted to 1.6 to 8.1% of the escapement. The great thing about the way this was designed, which is that it allowed for us to estimate the total run of both wild and hatchery origin salmon in Prince William Sound. What you see here is our two graphs. On the left are pink and on the right is chum. Within each species, there are three bars, one for each year of the study, 2013, 14, 15. The height of the bar indicates the size of the run during that year. And you can see for pink salmon, it goes up to about 150 million. And for chum, it goes up to about 4 million. And then the proportion of the bar demonstrates what proportion of that run was hatchery origin that was caught for the black, hatchery origin that ended up in the streams, that was red, natural origin caught, natural origin stream, then are the gray and the blue bars. This is the first time this type of information has been available. What we can derive from that is that the harvest rate on natural origin pink and chum salmon, again, this is natural origin pink and chum salmon, can range from about 26% to about 53% for pink salmon, and it was about 21% for chum salmon during the years of this study. We were also able to calculate or estimate the hatchery donor stray rate, which is the proportion of a hatchery run that did not return to the hatchery and was not caught. So this is the donor stray rate because these would have ended up in the streams. For pink salmon, that was about 1% to 5%. And for chum salmon, that was about 1% to 4% of the total hatchery run during those 3 years. What that equates to is a harvest rate of about 95 to 99% for these two species for the hatchery runs. That 95 to 99% happened during the same years when the harvest rate on natural origin fish was in the 20 to 50% range. The last question posed was much more difficult, takes longer, and is more costly to answer. Using cutting-edge technology and intensive field sampling, salmon offspring were matched to parents to estimate the number of offspring produced by hatchery and wild origin spawners in streams. This productivity then was our measure of fitness. This is a complex graph, but I'd like to take a little time. This is for pink salmon. On the left, you'll see in this graphic 2 columns. Each column represents a lineage, even year or odd year. Each row of graphs then is a stream, Herb, Gilmore, Hogan, Patty. Within the graph are bars. Orange bars are females, blue bars are males, and they're grouped by year, 2014 and 2016. What's being shown here is the relative return per spawner of hatchery fish when compared to natural fish in the same stream, the same year. The dotted line on each plot is at 1.0, which indicates equality. That relative return per spawner for hatchery origin fish was equal to the relative return per spawner or return per spawner for natural origin fish. So what this demonstrates for pink salmon is that hatchery fish have a lower fitness in these streams. This is again measured in the natural streams. However, there's a high variation. But it's about 50% on average across these streams in these years. It's important to note that not all these streams and not all brood years have been analyzed. However, this information has been published in the publication listed at the bottom of the screen here. We'll be doing a similar project with chum salmon in Southeast Alaska. However, we're in the last year of field sampling this year, 2023, and there is no analysis yet. Again, these results are communicated regularly and in public and professional contexts. There are 3 peer-reviewed publications for portions of the study. It's all available on the website, and of course, we've done multiple meetings. Lastly, I'd like to talk about the application of science to policy. In this example I've provided with the AHRP, It's demonstrated that it provides valuable biological information for understanding the interaction between hatchery and wild pink and chum salmon. It's addressing scientifically answerable questions, and it uses appropriate study design. However, to make this information useful for policymakers, we must provide guidance on how to interpret the results. And that means more than just biology needs to be considered. We also need to consider social, economic, and cultural issues. Thus, what happens is we've entered the interface of science and policy, which is where scientific knowledge is incorporated into belief and value systems to provide a bridge for decision making. So there are some questions that are not addressed by AHRP. These questions are important. They're valuable and they're necessary for application in some situations. So one of the questions not addressed is, what are the competition and predation effects of hatchery fish within and across species, within marine and freshwater habitats? Do hatchery fish reduce genetic resilience of wild populations? If changes in productivity are observed, what mechanisms could be driving these differences? How do these hatchery fish and wild systems affect assessment of escapement? And of course, on everybody's mind is, how will these findings affect policy? So application to policy may not be straightforward. For example, many mechanisms may drive the differences in measured relative return per spawner. It's very possible that this difference in productivity based on origin might be just a one generation issue and fleeting, or it might be an issue that goes on for many generations. Potential mechanisms for that would be, for this being a temporary or ephemeral effect, would be spawning ground familiarity, spawning in the wrong place, the wrong time. Hatchery fish can't be expected to know that because they came from the hatchery. Natural fish would have an advantage because they were born and raised in those spawning grounds. But it could also be that it's a relaxation of natural selection, and that that relaxation of natural selection and the very low mortality rate in hatcheries, remember I mentioned it was about 10%, could lead to changes in the genetics of hatchery origin fish, which, if integrated into the wild populations, could have long-term effects. There are many other mechanisms possible too: domestication, epigenetics, broodstock incompatibility, or for it being ephemeral, it could be related to timing associated variables like fishery prosecution or spawning ground competition or straying fish, delayed straying of fish. So I'd like to finish up with a quick example of one mechanism that we're exploring for this application of the results of this initiative to directing and changing policy if necessary. What I have presented here is a set of questions that we're calling questions for prudential or wise judgment. These questions are aligned to move us from the question of science down to policy or human values. What kind of questions? And all these questions are necessary, or ones like them are necessary when making policy decisions. The first one, does an event occur? I mean, that can be established in a scientific method just by having a well-designed observation program to see, do hatchery fish show up in wild spawning systems? If yes, then we've answered that question. That allows us to move on to the next couple of questions. How often, to what extent, and does that event have an effect? That requires measurement, experiment, and well-designed studies to answer those questions. And again, HRP was designed in our question number 2 to answer those questions. Now, the fourth one, we're moving now more and more towards policy and human values, in that it asks the question, is the effect harmful? We're approaching that with the difference in relative return per spawner, but the question about harmful requires us to have a standard. What is the standard to which harm is being measured? And finally, would addressing the harm cost more than it would benefit? This is kind of a cost benefit sort of a way of approaching it. It's not the only way to approach policy applications, but it's a good example that allows us to realize that this kind of a question requires evaluation by humans, by the public, by stakeholders and others. And those values then need to be collated and evaluated in a way that that allows for fair use of the resource. It was a rapid slide through about a couple hours worth of material. So I'm sure you have questions, but I'll stop here.
Okay, thank you very much, Bill. Very interesting presentation. Okay, we're going to move now over to Canada, and we have Shane Petersen here, and Shane will be speaking on the British Columbia Salmon Restoration and Innovation Fund, which is also known as BC SRIF. Shane is currently the Manager of Partnerships and Outreach for BC SRIF. He studied chemistry and oceanography at the University of British Columbia and parlayed that into a career with Fisheries and Oceans Canada that has spanned over 2 decades. He's held positions in DFO Science, the Aquaculture Management Division, the BC Introductions and Transfers Committee, and the Groundfish Management Unit. So thank you so much, Shane, and take it away.
Thanks, Bill. That was great. Lots of awesome info there. I'm only covering one initiative today, but we think it's a big one and quite diverse. So thanks to the Pacific Salmon Commission for having me and all the guests who came from fiscal year end or spring break or other to be here. Yeah, so I manage the team Caroline mentioned. That means I'm responsible for engagement on behalf of BC SRIF. And I also manage the team of biologists and project managers that are the technical expertise for the fund. I'd like to acknowledge we also have 2 other teams on BC SRIF. One is responsible for administrative and financial project management of the projects we fund, and the other team is responsible for our public, corporate, and governance reporting, respectively. So hi to everyone from the program. Keep going, here it is. Look at all this BC SRIF. So I'd like to start today a little different here, I think. I want to offer a review of our BC SRIF structure and some program outputs to date, including some brand new information about our relaunch, phase 2 as we call it, and our status under the Pacific Salmon Strategy Initiative, if you've heard of that. I'm sure you have. I want to do this because what I found so far is that when we lift the hood, when we try to dispel that black box perception of government programs, we increase that understanding of how we work. And most importantly, we increase prospective applicant understanding of how our program works. And in turn, their success with us as applicants and more importantly, those all important benefits for salmon. And then I'll get into salmon more specifically after that and those diverse ways in which BC SRIF has been able to support them so far. All right, so here we go with BC SRIF Genesis, which was within the, hold on, Integrated Fish and Seafood Sector Contribution Management Framework, a heck of an acronym, along with our other funds, the Atlantic Fisheries Fund and the Quebec Fisheries Fund. We're also going to look at our phase 1 structure, process, and some metadata here, and hopefully interesting. Where does BC SRIF phase 1 stand, and where is all that funding going? So I got a little picture here representing our BC SRIF partnership between the province and the department. So there's the former BC Premier, still feels recent, John Horgan, and the former Minister of Fisheries, now Minister of Environment, Climate Change Canada, Jonathan Wilkinson. They're announcing the original launch of BC SRIF. So together we provided $128.55 million in grants and contributions funding to applicants for projects. We run our fund day-to-day operations with a joint operations committee between DFO and BC staff. And our approvals run through joint management and steering committee with executives from respective governments. So the National Fish Fund terms and conditions, exciting stuff, base our fish fund program on 3 pillars that you can see: innovation, infrastructure, and science partnerships. BC SRIF is a broadly eligible program, eligible to Indigenous organizations, NGOs, and more as listed here. But you must be a stakeholder in fish, recent experience, fish habitat, fisheries, aquaculture, the fish world writ large, have to be in that world to be an eligible applicant. The initial BC SRIP funding priorities were quite high level, as you can see here. What I've done, habitat and healthy salmon, fisheries, and aquaculture respectively. Throughout this, I've kind of highlighted through some of these slides the most obvious levers where we can recommend funding for quality projects that provide benefits to wild salmon. So our terms and conditions also define us as an application-based program. We distribute our funding through a series of applications. Our first application intake resulted in 192 expressions of interest, EOIs as we call them here, requesting $327 million, or over 1/3 of $1 billion. So my language had to change to reflect these large amounts of money that we were considering and dealing with. And my eyes really opened to that passion, that intense passion in British Columbia to positively affect salmon. So because of this considerable interest in that associated volume, we advance applications, we deal in volume, we advance applications and projects in batches, as we call them. So the summation of our first application intake resulted in 3 batches of projects, 42 funded projects, $67 million in funding for those projects, and a 22% acceptance rate for all applicants. So I've highlighted this again. That's a tough shake for our first application intake. That's a lot of denials. And I'm going to revisit this acceptance rate stat as I go here. It was clear that guidance, templates, and transparency could all be improved upon in our original go. So let's improve our program as we go then. Let's evolve this organism, as it were, and let's recommend the rest of that phase 1 funding to good projects. As you can see, there remains so much interest out there. We had to understand it better. One of my take-home messages today, a huge point in grants and contributions, is you just have to understand the applicant base, those Indigenous and other stakeholder priorities for salmon here in the province. This requires so much engagement, most of it bilateral in nature. You can see over 140 sessions here that we had with folks trying to understand what they were interested in. Did we misunderstand your application if you were not successful? Did you find our process confusing and unfair? Are you a new applicant to BC SRIF? Let us understand each other better, basically. We also wanted to try being more specific here. So we've advanced 5 more specific funding priorities rather than that high level. So you can see aquaculture again here, community hatcheries, fisheries and seafood innovation, selective fishing, and species of concern. So even within these, there's so much variety, but I will get to that in a bit. Still lots of interest here, as you can see, another 126 EOIs requesting another $0.2 billion in funding. We addressed this via 1.1 batches this time of projects, $56.5 million in funding. Let's look at that stat again, shall we? And we've got a 44% acceptance rate. So that's great. And I think that now we're starting to understand each other as a program and applicants respectively. A new lesson from this process though, and you see that big 52 there, plus 3 more. When you make these type of recommendations and you approve this number of applicants, that is a lot of work to come. That is 55 individual contribution agreements for each one, a complex project, multi-year for the most part. It is so much work to negotiate those. And so, my kudos to program staff and my kudos to those proponents for working with us to do this in a timely fashion and to let that salmon work proceed. So this is our phase 1, as we call it, overall. 310 expressions of interest, $0.524 billion. Of all of that, 97 projects were funded. And at the current moment, considering the ups and downs of fiscal management of each single complex project, I can currently say we are fully committed to the tune of $128.55 million for phase 1. And our average acceptance rate, you can see here, was 1/3 of applicants received funding from us. So 19 of those projects are already complete, 78 projects are ongoing, and everybody's got to be done by March 31st, 2024. That's when phase 1 of BC SRIF comes to an end, the funding to go with it. So this is available on our website because in this context, that font is pretty tiny and maybe hard to read. We call it our placemat. This is a summary of those high-level funding statistics for our phase 1 funding. You can begin to see here some results with respect to our broad coverage mandate that we have for BC SRIF. First, to the type of proponent, Indigenous organizations lead 37% of our projects. But NGOs, stewardship groups, academia, industry, all run significant amounts of projects as well. Coverage, of course, is most frequently thought of spatially. You see our little map there in the corner, I hope. What we've seen is 36% of phase 1 projects are located in that most populous area of BC, which is the South Coast, as we call it. But again, you see reasonable coverage throughout the areas of the province, perhaps with the exception of the coast. Species-wise, as per mandated, salmon funding has been predominant. $71 million in funding has been labeled at that habitat and healthy salmon theme there that I mentioned at the beginning. But as you can see by the little graphic here, 84% of BC projects are actually salmon-centric. Therefore, $108 million of phase 1 funding has gone to projects with benefits. This is likely still an underestimate, I like to say, from a salmon ecosystem perspective, from that big tent view. No species exists in a vacuum, and projects involving sustainability advancements in non-salmon fisheries and even aquaculture, they can still provide positive, if secondary, benefits to salmon, of course. So, continued interests, needs for salmon, obviously never more dire. And some of the success we had, as described above, drove us onward to an unprecedented request for renewal of BC SRIF in year 2 of a 5-year program, so something that's rarely seen. So we pondered that bureaucratic feat of Treasury Board submission again. We realized that we need to better explain how BC SRIF met the diverse needs of organizations passionate about helping salmon and advancing sustainability more broadly, and how we could contribute and continue to meet those needs in an increasingly effective way. Well, also at this time, along came the Pacific Salmon Strategy, the PSSI. It was obvious that BC SRIF needed to harmonize with the PSSI. This is unprecedented. Particularly when we were informed that we had been absorbed into what we call Pillar 1 there on the left, conservation and stewardship. Also clear to see, despite being in one pillar, how BC SRIF could potentially provide significant funding to applicants across the 4 PSSI pillars, dependent, of course, on those external interests and our ongoing harmonization exercise itself. So here we go again. You've seen this already a bit. The BC SRIF recipe for responsibly distributing $128.55 million, another $128.55 million in funding. This time within PSSI for the department at least. We want to increase that process efficiency. We want to engage capitals I have here like crazy, primarily bilaterally again. We want to understand those concepts out there. Analyze them against our program criteria. We want to dispel that black box and just run it with you in real time before you apply and provide you with advice. Another launch announcement. Another picture representing DFO and BC partnership. So here now we have Minister Murray and Minister Osborne together and their colleagues and their host from the Musqueam. Funding priorities were updated once again, and principles were formalized to allow for additional priorities, particularly salmon projects. I'll show you that in a bit. Program pillars and eligibility remain the same, set in stone. So there's those pillars, but it's interesting here on this slide, we found to a degree what's old is new, again, with our third intake. I say that because we went back to three relatively high level funding priorities here: salmon ecosystems, salmon habitat more specifically, and sustainable fisheries. As you can see, we did make an attempt to bear down on salmon even further, and you can see some indication of the diversity within those high level priorities as well, and I'll get to that more in a second. Also below, you can see our very important principles that we always operated under, but as I said, we really wanted to formalize. Again, there's a real salmon onus here: climate change impacts to salmon, including disaster events, prioritization of salmon stocks, recovery potential, and urgency is a simple formula there, and that all important Indigenous participation and knowledge as well. So I can share a little bit with you what I am able to share where we are today. WAM, another 139 applications, another $0.35 billion in requests. 58 proposals, over 40% of applications received are from Indigenous organizations. But again, you see that healthy spread between stewardship, NGOs, industry, and academia. We remain salmon centric. 118 of our proposals are for salmon projects. As I mentioned, AIS, kelp, other species do have that large scale ecosystem effect on salmon stocks as well. And a pretty similar scenario here spatially as well, where that, most populated South Coast area of BC submits the most proposals, but good spatial coverage across the province as well. So this is where we are. What's red is done. What's black is to come. So I am somewhat bound here to secrecy and not getting ahead of myself, as one of my executives mentions. We are currently in batch 5, as we call it, approvals. We anticipate beginning to ratify new projects starting in April, and we're hopeful that we have that critical mass for an announcement as early as summer this year. More good projects. I wanted to make a quick note here regarding step 4, our referrals process. A question I get quite a lot is like, how can you possibly align this juggernaut with the PSSI and the work that the department and government is doing on salmon? How do you coordinate that effort? Well, the answer is my awesome colleagues to a large degree. DFO and BCA experts across the Pacific region provide advice according to their expertise. I think this was another unprecedented success for BC Thrift this round. Over 70 DFO experts alone were activated to provide advice on applications. What I observed from that was a cooperative exercise in ensuring that overall coverage and salmon benefits projects are maximized and coordinated with DFO efforts, PSSI in particular. Again, I'd like to thank my colleagues for their willingness and passion to contribute to that. So I am bound to secrecy, as mentioned, for some time, but I can say that we have proposed the largest batch of BC projects to date, which also represents the highest acceptance rate for applicants to date as well. So you've been patient, people, and thank you as we looked under the hood there. Let's turn to the plight of wild Pacific salmon and how we can support them through grants and contributions funding. With a broad scope like BC Thrift has, there are a lot of interesting and important avenues of support. I'm going to provide some of those avenues today with snapshots of various BC Thrift Phase 1 projects. So as Phase 1 projects, they were funded prior to and are therefore not officially associated with PSSI. Although, again, I think that connectivity is relatively obvious. And I've used some of the PSSI symbology here in the coming slides because I think it looks nice. So I'm going to start with a classic here, surprising no one. Funding can be used to conduct salmon habitat restoration activities. From monitoring throughout to assessing, prioritizing, and restoring important salmon habitat. This is typically a more expensive project type on average, given the costs associated with restoration activities. So Schwachem, Ducks Unlimited, and Comox are three proponents engaged in restoration activities in the Thompson River system, Fraser and Comox estuaries, respectively. More specifically, restoration can buffer against climate change, but it's also important to understand and prioritize where climate change is likely to be most impactful, as these three projects do. Nature Trust is partnering with several Indigenous communities to monitor and assess estuaries. PKIC is modeling and ground truthing numerous BC watersheds to determine potential climate hazards for salmon. And note the relatively modest UBC project, which is improving zooplankton productivity modeling. I note this because a grants and contributions program is ideally flexible, so that consider a range of project types, from the mega project, as I call it, down to the more discrete that you see here, from field projects to desktop projects. I think that's starting to be observable here on this slide. My joke was I was going to let Caroline take over here on this one, the IYS. I'll do broad strokes instead. It's important to understand the state of salmon and their stressors in the high seas environment and their high seas residents. So the NPAFC, credit to them, the IYS, they've succeeded in their Pan-Pacific survey in the face of both pandemic and a war. The data gathered in this endeavor will continue to advance high seas salmon science in the coming months and years. And below that, the Pacific Salmon Foundation, of course, has been there alongside to augment and to support that research as well on that. Am I still going? I am. BC SRIF has supported infrastructure upgrades at community hatcheries throughout BC. There's three of them here. I think in total, BC SRIF is able to fund infrastructure upgrades on 15 community hatcheries. I'm getting ahead of myself. Distinct from hatchery infrastructure is enhancement science. Bill spoke about that aplenty. I won't do that justice here today. There has been some funding under BC SRIF for enhancement science, including overall effectiveness of enhancement, better detection of pathogens in the hatchery environment, and impacts on otolith development in hatchery environments, respectively here. I do want to note that PSSI and our salmon enhancement program, SEP, we always say, have a great and ambitious agenda underway on community hatcheries and enhancement science, sorry. So BC SRIF has been happy to support that in a limited fashion, and we're really excited to observe a successful PSSI Pillar 2 led by SEP and led by DFO Science. What about salmon fishing, you ask? Indeed. BC SRIF has funded research in Indigenous, recreational, and commercial salmon fisheries. From the pound net fish trap, many here are probably familiar with, based on the Wild Fish Conservancy Columbia River model, to research in FRIM, fishing-related incidental mortality, and sustainability of commercial gear types. Can we better understand and reduce non-retention mortality? Yes, but what are you catching out there? Can we modernize how that data is gathered by enhancements in catch monitoring? Again, funding for Indigenous, recreational, and commercial salmon fisheries for this type of catch monitoring project. Integration and collaboration. How can First Nations and other organizations better work together to be more efficient and to affect positive change for salmon? Here's 3 examples of projects where modernizing practice, identifying priorities, engaging with the department and with each other led to efficiencies and advancements in this arena. So even with just these snapshots here today, you can begin to see where I get kind of my unofficial lingo for BC SRIF. We have a project for that. But what does it all mean and how do we quantify those benefits for salmon is a big question. So as an aside, I had a very keen, perhaps a little bit inexperienced colleague in Ottawa ask me, I think 2 years ago now, how many salmon stocks have recovered from BC SRIF funding? I'm smiling because the answer, of course, does not come that quickly as per Bill's slides there earlier. It's not even that simple within a specific project type, let alone the scope I've just gone over with you here today. So one thing is it's important to monitor projects in the field. We really want to ensure that salmon value for the funding distributed. So finally, some pie charts here. I know you've been waiting. 3/4 of BC Strip projects have a field component. Others we call desktop, as I mentioned. Since the launch of our strategic monitoring program in last year, we visited 44% of active field projects. It's also important to note that we monitor 100% of BC projects frequently, constantly. We do that by attending project management committee meetings. We do that by conducting check-ins. We constantly troubleshoot with proponents. And there's also our very important required annual results reporting. So as a manager, related to that, I had the good fortune to disperse my staff into the field to meet with proponents. What an opportunity. We've got the Kitsim-Kayla measuring sampling fingerlings here. There's some nature trust plans on the river. There's some Kitsalis plans for the Cleanza Creek. There's Gittinyao fish fence infrastructure. There's the Secretariat of Haida Nation using drone technology. There's the Wet'suwet'en and beach seining. I believe these are the credits here from these pictures. So in addition to asset and site verifications, ground truthing, if you will, monitoring allows BC SRIF staff to make informed recommendations to project teams in order to ensure the success of their projects. I have to tell you, listening to my staff present on these results too, some of the intangible benefits, those values to relationships between DFO and proponents, and the value of projects to the communities that we fund, it's just off the charts. So some highlights here, as I mentioned, from our annual reporting exercise. Proponents have declared to us over 1 million square meters of restored habitat. That's a big number and difficult to verify. We do not take measuring tape with us in the field, but impressive nonetheless. I struggled a bit with this next stat. 17 projects are currently focused on or contain salmon stock monitoring, salmon assessment activities. Most of those 17 projects deal with more than one salmon stock, so many, many more than 17 stocks are being monitored and assessed through BC SRIF funding. We're looking at a more complex analysis currently underway. The rough shake to start is about 2/3 of BC salmon stock management units receive some sort of BC SRIF funding, whether it's habitat, fishing, stock assessment, you name it. So we're supporting a lot of those stocks throughout the province, which is great. As I mentioned, 15 community hatchery facilities have received upgrades, and there's those enhancement science projects I mentioned to boot. Salmon fishing, fish traps, fish wheels, seine, rod and reel, fishing apps, you name it. BC SRIF has applied some funding towards research of that gear type, which is great. And that salmon science, so important, and Bill touched on this too. 25 publications, scientific or data sets have been released to date, and 43 are currently under production. Let's flood that lit, right? That's a lot of data that comes from all of that and across many genres of fisheries and fish management work, obviously. How do we maximize availability and coordination of data generated from BC projects? Not an easy task. As you can see here, PSSI is similarly mandated. How much is appropriate for assimilation into a data hub is referenced here? How can we do that? In the G&C world, Seafish, as we call it here, is continuing to evolve as a database. It can cover many of those hopefully interesting stats I started this presentation with. What is the data for G&C programs themselves? And how can we maximize the benefit of those programs, as I talked about? You know, and I know, ideally more data is made open data in a more timely fashion. We do know also from our experience that sensitivities to data are real and protectionism of data is real too. The coordination of so many data types, external and government, the harmonization of those data types, It's a challenge that shouldn't be understated for BC SRIF, for PSSI, for everyone. Again, thanks everyone for having me today. I hope my enthusiasm for grants and contributions and the good that it can do for Pacific salmon is evident. Studying this program in order to increase its effectiveness has been an amazing opportunity for me. I'll just hammer out those key lessons if they didn't sink in again. Engagement, and lots of it. Listen to applicants. Understand their intent. Explain your program. Increase acceptance. Analysis, and lots of it. How is the program performing? What is the feedback from applicants and colleagues? Can the program be more user-friendly, efficient, and effective? And coordination, and lots of it as well. From those passionate stakeholders advancing their projects and connecting with others, thereby forming a growing BC SRIF network. My colleagues in DFO and with BC coming forward despite their workloads, advise on how BC SRIF can complement PSSI and other government programs. It's humbling, and I'm grateful to be involved and to see what's possible when we all work together on salmon. So thank you.
Thank you, Shane. That was great. Your enthusiasm definitely came through. That was awesome.
So we have a few online questions. For Bill first. So this is from Gary Morshima, and Gary always asks tough questions. So, so he asks, what is being done to reverse the decline in Alaska Chinook stocks? First question, and then second, Alaskan salmon fisheries also harvest stocks produced by other jurisdictions. And how does Alaska fisheries policy or initiatives for sustainability and escapement goals apply to these stocks?
Hey Gary, good to see you're here, and thanks for the question. The first one I'm going to just rephrase it a little bit, because reversing the decline of Alaska Chinook stocks is not a question of improving habitat or necessarily even reducing fishing, because all over the state, harvest of Chinook salmon has been reduced. And in some places, it's been non-existent for a couple of years. Likewise, habitat is generally, the human effects on habitat is generally very small. Now, habitat is an issue because we have warming rivers. That affects adult Chinook salmon as they move up long rivers like the Yukon and the Kuskokwim. Reduces their health, and we've had dropout in the Yukon between assessment sites. So there's not a lot we can do to reverse the decline. What we're trying to do is learn where is it that we can find places where we could actually help, or at least forecast, so that we don't take fishing action when it can't be supported by the stocks. So things like a gravel to gravel approach, where we study all the way from egg deposition through spawner return, trying to find those choke points. I know it's not directly to reversing, but that's about the best we can do, because we actually manage people and not necessarily the fish themselves. In terms of non-Alaska stocks that are harvested here, that's also a difficult one. It's handled through interjurisdictional things like the Pacific Salmon Treaty, which all groups have signed on to the basic principles for the treaty, which includes sustainability and sharing of the harvest. Again, we don't set escapement goals, but we try to help and encourage others where possible through the CTC and the Transboundary Rivers committees to do what we can to help set escapement goals for others, or not us setting them, but help them insofar as possible. And then those goals, again, can be used to do things like sharing of harvest or coordinated reductions in harvest or even eliminating harvest, as we've done in the past on the northern boundary between Alaska and northern BC, where in 2018 and 2019, both jurisdictions drastically cut back harvests in order to pass fish into escapement. That's about as best I can give you right now.
Great. Our next question is for Shane. It's also from Gary, and it's, have species stock specific target outcomes been established for BC shrimp? And then also, whether do priorities include reduction of predation on salmon?
Thanks, Gary. Yeah, good questions. We are not a regulatory program per se, and so in that regard, we do rely on our colleagues, such as the Sustainable Fisheries Framework team within DFO, to affect those rebuilding plans that have been put into place by the government and determine those thresholds by which a stock moves from threatened or special concern up to healthy again, and allows those kind of fishing pressures to increase commensurately as well. Again, I think the analysis is key for a grants and contributions program like BC SRIP is what are you receiving from that all important applicant base? What stocks are people interested in working on? How do those relate in terms of some of those government handles to express the need of a given stock, such as CWIC, SARA listings, other Fisheries Act rebuilding regulations, all those kind of indicators that the government uses, again, to express the kind of urgency for a given stock. Also, coverage is really key, I think, for us. And so the Fraser River is an attention hog. I live right by the estuary, as I always say, but all of our funding cannot go to Fraser River salmon, although a significant amount of it does. We have interests throughout the province and needs of salmon throughout the province, whether that's the Skeena, the west coast of Vancouver Island, the central coast, even the Columbia I mentioned has been understood. So the kind of rambling answer, I mean, what we try to do is work well with our DFO regulatory and rebuilding programs in order to best understand how the work that they are up to and how that external GNC funding can most effectively dock with that work. And of course, that kind of resounds through the PSSI itself, whether it's the Habitat Restoration Center of Expertise, the Integrated Planning for Salmon Ecosystems team, Pillar 2 Community Hatchery and DFO Hatchery Investment Strategy, and then Pillar 3 Harvest Transformation throughout those fisheries. I've showed you some examples where BC Shrimp can support. Yeah, predation I can get to briefly as well here. It's an interesting one, and unfortunately there has been some defeatism that I personally witnessed. We can't cull seals, therefore what's the point? But I would like to break through that paradigm, and I hope that BC Strip has been doing that. We've seen some very interesting work. If we can't get to the cull stage, or if that's irresponsible or against those kind of species at risk regulations for certain types of seals, maybe we can understand predation better. And so we have some very interesting examples there, where the Chalmette Tribal Council, as an example, is understanding herring and modeling herring predation better on the west coast of Vancouver Island. Whales are eating a ton of herring, and nobody can do much about whales. We're hoping for their recovery, as everybody knows. And I can't say much. I'm a little limited here, obviously, in secrecy, but BC Strip hopes to advance some more interesting predation research and projects to come that we hope you're going to be hearing. Thank you for the question.
Thanks, Shane. So just being mindful of time, we have just a few minutes left. So Bill, turn it over to you. I know you put a lot of links to the web report. So the question from Urs is whether what information is available on the web for coho, as Alaska just started the GSI baseline for coho as part of the Chapter 2 treaty, and what's the hatchery output for coho in Southeast?
Urs, thanks for the question. I will try to answer them both at the same time to save some time. There is not a lot yet on Alaska's website for coho. in terms of the genetics work, because we're just beginning. But I will encourage you by saying that the work in Alaska is being coordinated also with the DFO laboratory in Nanaimo. And so if you're looking for information on the potential, I would take a look at some of the Terry Beecham's papers on coho salmon genetics in recent years prior to his retirement. Alaska's taking this on because it's also a domestic issue, not just a treaty issue, and we have increasing hatchery production of coho for mitigation from harvest reductions taken in the Pacific Salmon Treaty. So we need to do it responsibly. We need information, and to get that information, we need some genetics. Hope that helps.
Great. And since we've got two people talking, we'll have two people answering. And Shane, you get the last question. Are there projects to include collaboration for steelhead between the province and DFO?
Yeah, apologies, folks, if I'm cutting out. I will be more earnest and lean into my mic here. Yes, in essence. So the department assists the province, who is formally mandated for steelhead management and associated recovery. They do that through the Salmon Enhancement Program hatcheries, as you know. Our provincial partner is a 30% partner in BC Thrift, so they are quite keen to see steelhead sustainability, steelhead recovery advancements funded through BC Thrift. And so even as the DFO partner, we recognize when projects also feature steelhead benefits, and we do our best to advance those with our provincial partner as well.
Great. Well, thank you to you both for really great presentations. It's really fascinating to see the contrast between what you two are doing and similarities. Thank you again for everyone who attended, and look for recordings online soon of this seminar. And with that, enjoy the sunshine.